So these tutorials will be recorded and will be posted afterwards. And the tutorial slides are already posted on Quarkus. But it's still recommended for you to still come to the tutorials, and you can ask questions directed to me. So in the tutorials, we're mostly going to cover some of the more technical, detailed stuff that are useful for your milestones. So for the first tutorial, we're going to cover C++ templates and C++ standard template library, STL. And we'll start our first tutorial. So first question, what are templates? Outside of programming, you might be already using templates to create resumes. You might download a template from the web and you can fill in the fields with your name, experience, education, etc. And you make your own you make your own resume from the template. And one template can be reused for different people. The idea is similar in C++. So today we're going to answer what are C++ templates, how can I write a function and a class template, and when should I write templates. The idea of generic programming is a way to write code once that will work for multiple types, or it will work for different circumstances. In C++, we can template functions, classes, and some other stuff too that are not going to be covered. And if you wish to use it, you can go to the references or online and find it out. So today we're just going to cover the function templates and class templates. Function templates. Here are two examples of the swap function. For the swap function, we're taking in two parameters passed by reference. And in the function, we are going to swap whatever's in them. And the two swap functions, one is written for integers and one is written for doubles. They do the same thing, they have the same name. The only difference is the data type. So first, can anyone tell me, will this compile? Why or why not? Anyone? Yep. Yeah, because the two swap functions, even if they have the same name, they have different parameter lists. So that's called function overloading. The compiler will call whichever one called based on the parameter types. So what if we want to implement the swap function for all data types? The option one is obviously to write a function for each type that you're using. The positive is that it only supports the types that you want. No one will be calling this function for a type that you don't want to support, or it will be an error. But the negative is that you need to write a new swap function for each new type that you are adding, and that's a lot of copy and pasting. And if you want to change one copy of your copy and pasting, you'll need to change all of them. And in this process, you might miss some of them, which is not desirable, and it's very hard to debug. So to avoid the number of copy and pasting, we have the other option of writing a template where you can change the type. So the positive is that this will support all types that will compile according to your code, and it will avoid the copy and pasting by reusing the code. This could result in longer compile times because the compiler will need to do more work. This is the syntax for writing a function template. So on the first line, we use the template keyword to tell the compiler that we are using templates. In the brackets, we have the type name keyword followed by the name of the type that you're giving. So this type is a name that you give to the actual type that you're using here. And afterwards, you write the code and the compiler will search through the function being templated and replace all types with the actual type that's being called. And this function will compile if A and B are of the same type, because you're using the same type name for A and B. And it must have the assignment operator defined because it's being used here inside the function. Is this clear? To use it, we can either just directly call it with two integer values like this, it will work. Or we can explicitly call it with a double swap with two doubles. So in this case, if you explicitly specify double here, but you're passing in integer here, it won't work. This is just adding on another security for the template. So these are two usages for function templates. And now let's look at these 5 examples. So we have two integers ij, two doubles xy, and two characters mn. And we are calling swap in these 5 cases. Who thinks case A can compile? And we have a show of hand. Who thinks it doesn't compile? And why does it compile? Case A. Both are characters. Characters.
Oh, characters, bye-bye.
Yeah, both are characters, so it will compile. Who thinks case B can compile? Who thinks it doesn't compile? And why not? Can we have someone else to answer? Yep. One of them is integer, one of them is character. So it doesn't compile if they are not of the same type. Who thinks case C can compile? Who thinks it doesn't? Why not? Anyone? Yeah. Yeah. You're explicitly stating double, but passing in two integers. And case D, does it compile? Who thinks it compiles? Yeah, because they're all integers. And case E, who thinks it will compile? Who thinks it doesn't compile? Yeah, because you're passing in two doubles where it's specified as char. And that should cover enough usages. And now, as an exercise in tutorial, let's implement a templated minimum function where we are passing in two types of the same type, A and B, and we are outputting the value that is smaller within A and B. The minimum value within A and B. So let's go to this URL and complete the code under exercise 1. just exercise 1. You can split into groups and you can discuss. It's not marked. And we'll be back in 4 minutes. You just need to complete the code under exercise 1.h and test it yourself. You don't need to submit, just test it. Anyone needs more time? I'll move on if it's good for everyone. Okay, so your code should look something like this. And your minimum, if A is less than B, return A, otherwise return B. So when will this code compile? We have two conditions. Yep.
They both have to be of the same type.
Yeah, they both have to be the same type, and the other case. Yeah. Yeah. So the type must have the less than operator defined because it's being used here for comparison. Cases where the less than operator is not defined can be something defined on something allocated on the heap that doesn't make sense to compare. For example, arrays. And that's it for function templates. Any questions up to this point? Now, class templates. Applying templates to classes inside a class, you might have member functions and member data inside the class. So both of them can be templated. For example, you can template the type of data stored in the class, or you can template the functions, which type of data the functions operated on. So for example, you can have a templated array class that stores arrays containing templated types. Same thing for linked list and binary search tree. In this tutorial, I'll be showing an example of pairs. So a pair is used to store two pieces of data together. We can have a key plus value pair that's used for binary search trees for sort, where you have a key to be sorted and the value being stored, or vice versa. The key and value pairs may not be the same type. Say we have a key of a string name and the value of an integer. And in this tutorial, we are going to create a class that can store two arbitrary pieces of data, first and second of any first type and second any second type. And this can be used in arbitrary classes like binary search tree, linked list, and anything like that. So here are examples of two instantiations of the pair object. The first one with a type of string, and the second have a type of integer, and first have a type of double, second has a type of string. So they're templated so they can have any type. Here is the example code for the pair class. Similar to the templated function, we have on the first line template. And within the bracket, we're defining two different types, first T, second T, separated by a comma. And in the class, and then the class name, and inside the class, we have the constructor. We have the setters, getters, and the private data members. Something to watch out for is that if you are templating a class, you have to write everything inside the header file. If you split some of it in the header file and the definitions in the C++ file, it won't work because the compiler will need to look right into the code right after the template keyword. So you have to define everything inside the header file for the class. So like this, inside the header file, you'll need to define the constructor, the setters, getters, and all of member functions. Using the pair class will be first, we specify the pair and the two types inside the brackets, give the pair a name, and then call the constructor, where the first object is an integer and the second object is a float. And then we can just use the getters and setters as usual. Like this. So the compiler will create the respective pair classes based on the parameters you're giving here inside the brackets. Is this clear? Okay, I'm going to go into the first demo. And for anyone not using iControl is a very useful tool because it helps you switch to a machine with low load. To the demos here. Let's read the code first. So in this example code, we have a templated maximum function where we're returning the maximum value within A and B. And inside main, we are calling it first with two doubles, second with two integers, and third with two doubles. And for the demo, we should start from here. Okay. And let's compile. And here's the compile message. The idea is to not be overwhelmed by the long compile message because all the lines that are not the actual error are here to help you. So we should always be starting from the actual error message. So what the error message says is on the 17th line of my max.cpp, we're seeing no matching function for a call to max, double reference, and int, which is this line. And it's giving the suggestions that we have the definition of a templated class max with two types, two parameters of the same type. And in here, it says the deduced conflicting types for parameter t. We have a double and an integer. And from the line, it looks like the compiler is recognizing 2 as an integer, not a double. So what we need to do is to explicitly tell the compiler that the 2 is a double by doing this. Okay. This is actually a very common mistake because people will assume that 2 and 2.0 are the same number. And now the compile error is gone and we have the program running correctly. Okay, any questions for the demo? We can get back to tips for writing templates. The first step is to not write templates. In this course, at least. Because template errors can be very complex and overwhelming, especially for beginners. But you should be using templates, which is why I'm teaching you templates here. So there are many template functions and classes existing. We have the expensive standard template library for you to use, and there are other libraries out there that you can use freely. But if you do write templates, just make sure that you're writing the code for one type first. Make sure it works by testing it, then convert it into a template, and then test it again with different types. In this case, you will be saving a lot of time debugging. And this procedure should be the same procedure that you're doing for any complex piece of code to save your time debugging. Okay. The second half of this tutorial will be on the standard template library, and we usually take a rest here. Anyone wants to take a break here, or do you want to finish early and go home? Okay, we'll skip the break and we'll just directly continue the second half. The standard template library is something that you'll need to use if you write C++ in any time of your career. So today we're going to cover why should I use the STL, and we're going to be using vector as an example. So as mentioned previously, writing templates can be difficult, and using templates is much easier and more productive because the templates written by other people are optimized and refined over the years. So, for example, if you write your own sort function versus using a templated sort function that's optimized by other people, can be a very straightforward comparison. So the STL has a lot of things that you can imagine covered, like swap, sort, pair, min, and so much more that you should be exploring by yourself. The containers library, from the name, it contains containers that are data structures. For example, list is a doubly linked list of some type that's templated. A vector is a dynamic array of elements of some type that's templated. And the usage is the same as the templated classes. First, specify that you're using vector and specify the type to be templated. Why do we use std vector? In what circumstance do we use std vector? If we want to read integers from the user to an array until the end of file, then do some work on the array. In this case, you won't be able to know how many integers you're going to read until you have saved all of the integers. So what we need is something that can grow in size while we're reading in all of the data. We could use linked lists, but lists are inefficient, especially if we want to do some work on the array later, because accessing an element we'll need to go to the head, we'll need to traverse through the list, and that's O(n) time in complexity. So the better solution is an array that can grow dynamically, and we can access an element with O(1) time, like an array. So vector has all those covered. For accessing elements, it has the operator square brackets so that you can use it similar to an array. You can read it like this, and you can write to it like this. It has the function to push back new elements. The pushback will grow the array in size, and it will put whatever is inside the parameter into the end of the array. Because it grows in size, if you need to know the size at any time, you can call the size function. So the code for accepting integer input into a vector will look like this. First, we'll need to include the vector header because we're using vector from the STL. And then in this function of get integers, we are returning a vector of integers. And inside it, we are creating an empty vector of integers using the default constructor of vector. And then we can just read in the values and push back the value into the vector of integers. Yep.
Before so like I've seen element requires O1, like how does it take O1?
Access an element
Yeah, like, oh, yeah.
here. So for any array, accessing an element requires O1 time because it goes into the place where the array is. And then because it's continuous in the memory, so it just adds the index to the head of the array and access that.
Go to the list, like because if I want to move to relative, I have to go from start to the point where it is, right? But it takes n times. I don't understand how it will take just one, like how will it directly find in the place.
For a linked list, you access with ON because you go from the head and you traverse. But for the vector, you can go to the head, you can add the index to that address, and then you can just directly access. Yeah, because arrays are stored continuously in memory. So you can directly add the index with the address. So in this case, we push back all of the values into the vector and return the vector. And pushback will make the vector grow in size to accommodate new elements. So after we take in all of the integers into the vector, exercise 2, use a for loop and print out each element in the vector and integers using the operator square bracket and the size function. So let's go back to code word and complete the code under exercise 2. It's the same procedure as before. We'll be back in 4 minutes. Remember, we just want to use a for loop to print out each element in the vector. Anyone needs more time? If no one's saying anything, I'll move on. So this is what your code should look somewhat like. So in this case, we are having a for loop that goes from 0 to 1 less than integer slot size, and see out integers square bracket I. And in this case, it's separated by space and followed by a new line at the end. So how does the STL implement the vectors behind the scenes? So we assume that at the default definition of the vector of integers, we assume we create an object with an array, size of 0, and initial capacity of 3. So the array initially points to an array allocated with 3 slots. This is not what actually is happening. We're just assuming the number 3 for now. So the default constructor will create something like this. And after we read in the first input and pushing it back, we increment the size by 1 and put the first input into the first slot. The second input, we increment the size by 1 and put the second input into the second slot. And same for the third input. And when we are pushing back the fourth input, because we are exceeding the capacity of 3, the vector class will then create a new array of capacity of 2 times size. So it's doubling the capacity of the original array. It copies over everything from the old array into the new array. It deletes the old array and points the array pointer to the new array to avoid memory leaks. And then the capacity is now increased to 6, and we can read in all the way until 6. And end. The algorithmic complexity for pushback is actually O1. Even if we are doing the new array allocations and keep copying, because we are always doubling the capacity. And with the doubling of capacity, the actual capacity will grow very quickly. So the amount of copying will be small enough that can be negligible. So on average, pushback has an O1 complexity. That could be slightly slower with a fixed size array. Vector has 3 different constructors. The first one is the default constructor that creates a vector of size 0. The second one can create a vector of size, initial size of a number specified in the parentheses with values unspecified. Third one creates a vector of size 10 in this case, and all the elements are assigned initialized to -1 in this case. So instead of using the default constructor, if you have an idea of the final size of the vector, specifying the size in the first place could speed things up by a bit. So let's do a comparison of arrays versus vectors. In this code, we have 2 arrays, A and B. dynamically allocated with size 10. We have two vectors, v1, v2, constructed with size 10. We can access the elements the same way. And the two dynamically allocated array need to be destroyed at the end. Now let's look at these two lines. When we do A equal to B, what happens? Can anyone tell me what happens? Yeah, the pointer of A will point to B. And whatever was in A will be lost. So that's a memory leak. Now, what happens when we do V1 equal to V2? Yep. It won't make a new array, but it will do a deep copy of copying the contents in V2 into V1. Yeah. So V1 and V2 will still point to different places. Do we need to delete V1 and V2? Because the definition of the vectors V1 and V2 are on the stack. And whatever was dynamically allocated inside the vectors will be cleaned up by its own destructor. So the tip is to avoid writing pointers yourself and let the library manage the memory for you, because memory leaks will be tested during marking of your milestones. But vectors has something that's not really good, which is that the operator square bracket does not check bounds. If you are reading from some place where the value is not defined, where the vector is not defined, it will return some garbage value without telling you anything. If you write to it, your program will crash with segfault. So for the milestones, you can use the debug check configuration to do bounce checking with memories, but this will make your program run more slowly. And I'll show you this later in the demos. And the no bounce checking feature with the operator square bracket is actually a design decision made by the developers of the STL, because bounce checking will make the vector run slower. So random access to data with the operator square bracket is then O1 complexity, because it directly accesses the memory without any bound checking. Okay, I'll move on to the demo if there's no question. The first one, I'll show you why the debug check build is your friend. I think you should already be going to the labs, but I'll still show you. What I'm seeing in the lab is that people are opening the VS Code from the menu, which shouldn't be happening. What you should be doing to open the VS Code is to CD into the repo that you're working with and do code, period. This will open the VS Code with the correct version that you should be using. And a lot of weird errors I'm seeing with VS Code are because people are not doing this. And here is the example code we're looking at. So in here, the test vec has a test vector with 100 elements, initialized to 20. And as you should already be seeing, we are accessing out of bounds memory here. And in here, we're setting the 0i to be 20 plus the index I, and we're outputting the number here. So what do you expect this code to do? We're writing to out of bounds memory and we're printing them. What do you expect this will do? Yep. It accesses out of bounds. So let's see whether it crashes or it gives out any errors, warnings, anything. You make a do release configuration first, because that's the thing that we're always doing. Wrong. So it's successive. So it successfully finished. And remember, we are adding the index with 20. So it's correct up to this point. And starting from 100, it's throwing out garbage values and it's not even crashing. Let's build it with debug configuration and see what happens. We need to make clean because we didn't make any change to the code. Same thing. And let's do debug check. Make clean, then debug check. And you should see all of the compile flags that are being used here. F sanitize are the ones that are related to memory checking. And let's run this. So the program runs up to 99. And then in here, it says in some vector, we're attempting to access out of bounds index 100, but the container only holds 100 elements. And it's a vector of integer. That's the only information given by the debug check in this case. So from these hints, you should be able to go to your code and look at your vectors and see which ones have a size of 100 and fix it. Is this good? And the idea is, this is what debug check does for you. Not release, not debug. And the last demo, we'll do a speed comparison. The first one, how much do the compiler optimizations impact runtime? We'll be doing release versus debug check. Do we have an hypothesis of what will be happening? Who thinks release will be the fastest and then debug and then debug check. Okay. Vector versus arrays. how fast will be vector versus arrays? Any hypothesis on that? Yep, arrays. Arrays are O1. So vector versus arrays, if we're doing this on a sufficiently large vector versus array, they actually should be quite similar. Vectors could be a bit slower, but they should be quite similar, right? How about Python versus C++? C++ is faster. And how faster? How much faster? We'll see it in the demo. So, as usual, let's read the code first. So we have a big enough number of elements. And for the vector, I'll be just using this code, and switching to array, I'll comment out this line and uncomment this line. And it will do something to both of them. Go back to the terminal and do the release configuration first. And I'll time the vec versus array speed. So the hypothesis was this will be fast. How do you read the output from the time command? The first number is the amount of time spent in the user program. This is the number of time spent in the system kernel. And this is the actual time that's spent by the program. So this is the time that we should be reading. 0 is in minutes, and the 0.46 is in seconds. So the release configuration took 0.46 seconds to run. And let's do a make clean and time the debug configuration. Debug. Time. 1.02 seconds. So this is about 2 times lower than the release configuration. And let's do a make clean again and do the debug check. Time. 6.81 seconds. So that's about 14 times slower than the release. So whenever you need to do anything with performance measurement, always measure the release time. And this will also depend on the machine load at this time. I chose a machine with low machine load, so it has negligible impact on the runtimes for now. Now, let me switch to array versus vector. And I'll make it with the release configuration so that we are comparing the same things. And let's see the speed. 0.44. So that's about the same speed as vectors. So vector and arrays are on average are having the same speed because they're both O1s. And the last one is Python versus C++. So in the same folder, we have the Python file that's doing the same thing. This file is shorter than C++, and that's because of the nature of the Python, because it's just typically easy to write. And let's find the Python execution. (23.47). So that's about 47 times slower than the C++. So this is even slower than debug check. Okay, so any questions on the demo 2? Okay. So if you want to learn more about the C++ and the STL, we have these resources, especially the online resources and Google. You should be looking for your own container to use during the milestones. We're going to give some help to some extent, but if you want to optimize for your own performance, it's recommended that you look for the best containers that best fits with your usage in the milestones. And that's it for today's tutorial. Thank you. If you have more further questions, I'm here. Yeah? Container?
Yeah.
Container is just something in the containers library. Like a vector is a container, array is a container. It's just something that holds data with some structure. Yeah. Int is a type. A container can hold different number of ints.
Yeah.
Yeah. Yeah.
How do you open terminal?
We'll go to application, system tools, and make
Okay, so you want to like CD to wherever the working, like the coding,
yeah, CD to your current
like
directory.
how,
So it's
how do I even know?
ls.
Well, I guess. Oh, so if I want
It's ECE297.
and then I just call it like this.
It should be your milestone 0.
Oh,
So close this.
Yeah.
CD work. Then code. Yeah.
okay. Oh, so it will show like the main and Git as well.
And it has the makefile extension here.
Okay.
Yeah.
Okay. I thought you wanna like always code to like switch to ECE297 so you can access both work and the Git like files. Like,
No, I mean
Okay.
always go to your working directory and open the VS Code in there.
okay.
Because if people are opening VS Code elsewhere and
Okay.
opening the directory in there, it will have like
Okay.
very weird problems with
Okay.
VS Code.
Okay.
Yeah.
But what if you want to access the like the master folder of 就是上级菜单，就是如果你想 access 它的上级菜单怎么办？